the first one, if you want to determine if a number is rational, that means it is a number that does make sense. Anytime that you take the square root of it, if it is a decimal that stops, that's good. Or if it's a number that can be written as a fraction, that's also a rational number. So the first thing you do is type 0.07, square root of 0.07 in the calculator, and you get 0.02. That is a rational number. This number is irrational because these dots tell me that it's going to keep going on forever and ever and ever. So that's not good. That's irrational. And then this one stops at 0.25, so that makes it rational. 0.25 actually can be written as 1/4, meaning this number can be written as a fraction. Therefore, the first and the third are both rational. For question number 2, this says solve for x. In order to solve for x, you undo the things that are happening to it. So the first and biggest thing that's happening to this problem is that we're dividing by 4. To undo dividing by 4, we multiply both sides by 4. So I'm going to multiply both sides by 4 here. What happens is that it's going to be equal to 28, but this 4 and this 4 cancel out, leaving us with 6x minus 2 on top. Once you have that piece done, then all you have to do is get x by itself by adding 2. So we'd get 6x is equal to 30, and then to get x by itself, even though I ran out of space here, I would divide both sides by 6. So that means we get x is equal to 5, because 30 divided by 6 is 5. On the next one, I'm going to make my space a little bit bigger so that I can do it and you can read it. We're going to solve for x doing the same idea. Okay, so we're going to solve for x. In order to solve for x, we've got to do a couple of things. The first thing you might notice is that we have a -2 in front of this set of parentheses. We have to multiply it to both things. Before we do that, though, this 3x has to drop down. The other thing that's tricky about this problem is that there is a -2 in front. So that means -2 times 4x, which gives me -8x. And then -2 times 5, which gives me -10. A lot of times kids would accidentally forget about that negative symbol with the 10, so just be careful as you go through it. So this is going to be equal to -25. And now on your test, a lot of people made some mistakes on this because they started moving things left and right. Before you move things left and right, you want to combine like terms. In order to combine like terms, the only things that can be combined on this left-hand side are the two x's. So if we have 3x and a -8x, we can combine those together and give me -5x. The rest of it drops down. So another common mistake is that you may accidentally forget to put the negative symbol with the 5. Pretty common. So now we have an x and then we've got two numbers. So we need to move the numbers to the other side to combine those like terms. So again, we're combining like terms. So to get rid of the -10, we need to add 10 to both sides. When you add 10 to both sides, you have -5x is equal to, now be careful when you type these things into your calculator because you have a -25 and you're adding 10. So that gives you a grand total of -15. And here I am again with very little room. The last piece that we have to do to get x by itself is divide both sides by -5. So again, this one's riddled with possibilities for those negative symbols to mess us up. In your calculator, if you typed in -15 divided by -5, that's going to give you x is equal to +3. The next set of questions says, how many solutions are there in the following equations? And here's our hint. It says there could be one, there could be no, there could be infinitely many. If you have infinitely many, the way that that would happen is you'd get like a number 3 is equal to 3. That's always a true statement. No solution would be like getting 0 is equal to 3. That doesn't make sense because 0 is not equal to 3. And then one solution means that you'd actually solve for x equals some number. So again, we just got a lot of algebra to do with these where we're solving all of the pieces very carefully. So I'm going to zoom this in. The first one, we're going to distribute a bunch of stuff, bless you. So we get 6x. Distributing that 3, you have to do that to that one too, plus 15 is equal to 10x drops down. And then we have -4 times x. That gives me a -4x. And a -4 times a -2, which is a +8. And you can rewatch this video as many times as you need to just to make sure you got all the pieces right. All right, before I start moving things left to right, I need to look to see if I can combine like terms anywhere. So on the left-hand side, there's nothing to combine, so that one's good. On the right-hand side, though, we do have a 10x and a 4x that we can combine. So we've got 6x plus 8, and then on the left, I just dropped everything down. What we have right now can actually tell us what our solution set's going to be, because we have a 6x on the left and a 6x on the right. But one of them's adding 15, the other one's adding 8. So they're slightly different, meaning they're not equal to each other. Now, if you wanted to go through the step of like simplifying completely, you could subtract 6x from both sides. Although you could probably just get your solution here. If I subtracted 6x from both sides, I'd be left with 15 is equal to 8. And this is one of those situations I mentioned when you have a number equal to a number that aren't actually equal, that's a no solution. B looks like it'll be a little bit nicer because we don't have to do any distribution. We just have to simplify to get x by itself. To do that, we can move numbers around or we can move variables around. It doesn't make a difference to me which one we start with. I'm probably going to move this 2x. There are 4 different ways of doing this problem, starting this problem. You could have chosen the 2x, the 1, the 3x, or the -5. So you can do it any way your brain thinks. You just have to make sure to show your work. We'll get the same answer. So on the left-hand side, I have a positive 1 left, and then I have 3x minus 2. That leaves me with x, and I drop down my -5. Now, the only thing that I need to do is combine my numbers together, so I'm going to add 5 to both sides, and I'd get x is equal to 6. So that means this one has one solution because we actually figured out that x is equal to 6. So one solution. Here we are with another crazy number, or letter C, lots of distribution, lots of parentheses, lots of numbers here. So we're going to start out small, distribute everything, so we get 8x minus 4 is equal to 2x plus 3 times 2x, which is 6x, times 3 times -2, which is -6, plus 2. Whew. All right, so we've got a little bit of stuff on the left-hand side, and we got a whole slew of things on the other side. So the first thing we're going to do is start combining like terms. So 8x minus 4. Then we have 2x and 6x gives me 8x. A -6 and a +2 give me -4. So this one is at least nice because you can see if you simplify, you get the exact same thing on the left and the right. When that happens, that means you have infinitely many solutions. Infinitely many solutions. The reason, just to highlight it, is that that statement is true. 8x minus 4 is equal to 8x minus 4 because they're exactly the same. If it had said 8x minus 4 is equal to 8x plus 4, it wouldn't be the same true statement. All right, more solving. Number 5. Number 5 means, or starts out by setting each, I'm trying to decide my color and I can't think about it, setting each variable together and each number together. So we've got 10x minus 4 is equal to 3x plus 10. Again, you have 4 different ways you could solve this problem. It doesn't matter which way you do it, as long as you start to solve. So we've got a 10x and a 3x. I'm probably going to subtract 3x from both sides. The reason I'd subtract 3x from both sides is that it keeps the variable positive. You don't have to, though. It doesn't matter to me. That means I would be left with 7x minus 4 is equal to a positive 10. Next step is to get x's by themselves. So we're going to have to add 4 to both sides. We get 7x is equal to 14. And then I divide both sides by 7, leaving me with x equals 2. Inequalities are a little bit different, only that you get a final answer, and then after you have your answer, you put it on a number line. So everything else remains the same. All of your algebra skills remain the same. This is slightly tricky because it has a negative in front of the parentheses. I would suggest putting a little 1 in front of the parentheses so you know you need to distribute that out. So this becomes 2x drops down. Negative 1 times 4 is a negative 4. Negative 1 times negative 3 is a positive 3x. Plus 1 is less than or equal to 4x minus 1 drops down. Now we're going to combine like terms. When we combine like terms, we're going to combine our x's together. So we get 2x and 5x, which is 2x and 3x, which is 5x. So you got 5x, then you have your negative 4 and your positive 1. Combining those would give you negative 3. There's nothing else on this side. Now we just need to combine like terms like we would on any other solving problem. So we have a 5x and a 4x. I would subtract the 4x from both sides so that my variable stays positive. So I'd get x minus 3 is less than or equal to negative 1. That's where a common mistake will happen. You guys would accidentally put the 1 down there, but forget to drop that negative. So just be really, really careful with negative symbols. The last part is to add 3 to both sides. When you add 3 to both sides, you end up with x is less than or equal to positive 2. So normally this would be our last step, but the problem here is that we still have to go through and draw it on a number line. The number line means anywhere there is a normal number that's important, in this case 2, you either decide to put a closed dot or an open dot. In this case, this one's going to be a closed dot. And the reason that we know it's a closed dot is it has the little equals to underneath. The next thing is that this says less than. So numbers that are less than 2 are numbers to the left-hand side. So technically this one does say just solve each inequality, but if you had a number line that you had to look at the solution, this is what the solution would be. So I'm not sure if you have to actually graph it. I think we just have to solve them. So I went too far on that one, but we'll talk about closed dots and open dots here shortly. Number 7. Number 7, again, this is all these parentheses. These will be as tough as they can get. If you can do these, you're a pro. 3 times x. 3 times 6 is 18. Minus 4. Greater than equal to x stays the same. And then we have plus 2x. Make sure you distribute it to both pieces. So 2 times negative 8 would be negative 16. Now we're going to combine like terms together. On this left-hand side, I'd have 3x, and then we'd have 18 minus 4. So that's plus 14. On the right-hand side, I have x plus 2x, which is 3x minus 16. So what happens here is you're going to have two pieces. It's different from the last one because if you do simplify, you could subtract 3x from both sides to combine like terms. And then you'd get 14 is greater than or equal to negative 16. So you have to read what the statement says. The symbol itself says greater than. So the question is 14 greater than negative 16? Is that true or false? True. So since this is a true statement, that means we're good. There are infinitely many solutions. So if it becomes a true statement, it's infinitely many solutions. Number 8, we're going to do the distribution again. So we're going to have 5x, 5 times negative 3, minus 8. Whew, these are rough. And then 2x plus 12 plus 3x. This is like the Olympics of solving equations here. So we have 5x. So negative 15 minus 8 is negative 23. Combining 2x and 3x would be 5x plus 12. So you can either do that combination now or you can do it later, it doesn't matter. But what you end up having here, again, you have a 5x on one side and a 5x on the other side. So you want to get rid of that 5x and see if your statement is true or false. Here's the trick. If you forget to drop that negative down, it'll mess you up. So we get negative 23 is greater than 12. So this is saying greater than 12. Well, in this case, negative 23 is not greater than 12. Therefore, this statement is false. If it is a false statement, that means there are no solutions to this problem. So the next ones are the same idea, except we get x by itself and then graph both of them together. So compound inequality just means on the same number line. That's it. So the first thing we're going to do is add 4 to both sides on this one on the left. So we get 2x is greater than 10. And to get x by itself, we divide both sides by 2. If we divide both sides by 2, we get x is greater than 5. That's our first part of our equation. The next one, we solve to get x by itself too, and then we're going to graph them together. So subtract 6 from both sides. We get 4x is less than or equal to 32. We divide both sides by 4. When we do that, we get x is less than 8. So like I said, all we have to do for compound inequalities is graph them both on the same number line. So I'm going to use this space right above this and put them both on the same number line. So I'm going to do the blue one. That number is at 5. 5 is smaller than 8, so 5 goes right here. It is just a greater than symbol. If it's just the symbol with no line underneath of it, it is an open dot. You can make the dots really large and obnoxious. So open dot. That inequality says x is greater than 5. So that means we're going to be shading this direction. We also have x is less than or equal to 8. So we have to put 8 on our number line. That one says less than or equal to, so it's going to be a solid dot. And like I said, this one says less than. So it's looking for all the numbers that are lower than 8, which means we're going to be shading this direction. The solution set for this one is in between because that's where both are double shaded. So B is going to look very similar, but the answer, whenever you do the number line, you do the same process, but whenever you do the number line, it's going to be pointing opposite directions. So either or should point opposite directions. So 2x minus 1 is greater than 5 means we would take 1, get rid of the negative 1 by adding it to both sides. So we get 2x is greater than 6. Then we would divide both sides by 2. You divide both sides by 2, you'd get x is greater than 3. The second equation, I'm going to do that one in green. We're going to do the same type of thing, but this one has a hidden potential for error. We've got a 4 and a 16. Those are the first numbers that have to be combined. So our 4 was positive. We have to do the opposite of that, so we need to subtract it. So we get negative 3x is greater than or equal to 12. And now something very crazy happens here. We're dividing by a negative. Anytime you divide by a negative with an inequality symbol, you have to change the inequality symbol. Good catch. So we're going to divide by a negative, which means we'd have x, and then you guys are right. It flips to less than or equal to negative 4. So now we're going to put both of them onto the same number line. The gold equation has a 3 in it. 3 is larger than 4, negative 4. So we're going to put 3 on the right-hand side. This one doesn't have the equals underneath of it, so it's going to be open. And it's telling me all the numbers greater than 3. So it's all the numbers to the right-hand side, like 4, 5, 6, so on. Negative 4 is smaller, so it's further on the left on the number line. That's another equals to, so it's going to be a solid dot. Again, this symbol says less than. Since that symbol says less than, we're looking for numbers lower than that. So that's on this side. So for these questions, you didn't have to actually graph them, but it is a representation showing you the either and the or. Again, these are multiple choice. So when you go through your multiple choice test, you have to be careful to choose them correctly. 10A and B are writing the equation. So this kind of helps us lead into those questions because the important numbers are 1 and 6 in the first equation because those are the ones with the dots on them. They are only going to have either a less than or a greater than symbol. And then when you write the statements, you always put the x value on the left-hand side. There's one exception, and it's the next one. So at 1, are the numbers going to be less than or greater than 1 based on the shading? So since it's shading to the numbers lower than that, it's going to be less than. For the other one, notice these are open dots. So that open dot moving past that means that all the numbers are going to be greater than 6. B is very similar, except the shading for B is actually taking place between the two expressions. When it's between the two expressions, it is an and statement. That and statement can be written two ways. The easiest way to do it is by putting x smack dab in between the two numbers. And then you just figure out if the symbol has an equals underneath of it or doesn't have an equals underneath of it. In this case, both of them do not have an equal sign underneath of it. So you put two inequalities that go the same direction. Now, this might be written as two inequalities like number 9a. In that case, you would have x is less than 2, and you would have x is greater than -3. Either one of these statements tells you the right answer. More commonly, you're going to see the blue one in every course beyond this course. Slopes should be pretty good, should be pretty easy. I feel like you guys could do well on this section of the test. So for this one, slope is always rise over run. So for these, you are literally counting the top number is how many they go up and down, and then the bottom number is across. So this one, the points are clearly marked, thank goodness. This goes up 2 and it goes over 1. So that means its slope is 2 over 1, but you would probably see that just as plain old 2. The next one goes up 3 over 1, 2, 3, 4, 5 blocks. So up 3 over 5. You have to be very careful when you see a number that falls from left to right. If you see a number that falls from left to right, please take a moment to put a negative symbol or cross off the ones that are positive. So when you do a multiple choice test, eliminate the answers that don't make the most sense. So we get negative from point to point. We went either, you could call it up or down. I'm going to say down 2. So down 2. And then we went over 1, 2, 3, 4. So -2 over 4. That wouldn't be what an answer choice would be because it would simplify. And you guys should be able to do that. -2 over 4 simplifies to 1/2. And maybe on number 11, if you remember watching Slope Dude, it would help you on this one. So you can always look up Slope Dude. This is zero fun. Going through an entire Algebra 1 review is tough. Sometimes it can be zero fun. This is an example of zero fun, meaning it has a zero slope. If it goes horizontally and has no rise, that means the rise is 0 over point to point was 5 points, which is just 0. You guys did well on calculating the slope. Again, it's rise over run, so it's y minus y over x minus x. You have to just keep your y's in the same order. Typically, the formula is y2 minus y1 over x2 minus x1. I always do it in the order that I see it. 11 minus 4 And then on the bottom is -9 minus 3. I even put these little dashes, like this is something that I always do ceremoniously, I guess, I don't know. If you wanted to do negative or 4 minus 11 and then 3 minus a -9, you can. 11 minus 4 means that I'd have 7 on top, and then -9 divided by, or excuse me, -9 minus 3 is -12. So that means my answer choice is D. Last one is to graph our lines, or last set is to graph our lines. If you're graphing your lines, you guys did really strong with this at the end of the semester. This is your starting point. This is your B value. So you put a dot at -1. And then your rise is up to over 5. Take the time to write your little arrows because it tells you how to do it. Up to, over, 1, 2, 3, 4, 5. And yes, you could do the exact opposite. You could go down 2 and to the left 5, down 2, 1, 2, 3, 4, 5 to go in reverse. Double check when you have a line drawn or from your multiple choice options that it is a positive slope line if there's a positive slope. Last one starts at 5. 1, 2, 3, 4, 5. And then the slope goes. So the negative is in front. The negative is in front of the 1/3. So it can either be -1 over 3 or it can be 1 over -3. It does not make a difference. Typically, you guys just let it float to the top. So we're going to go down 1 and to the right 3. Down 1, 1, 2, 3. Negative slope lines mean you're going to move the opposite direction. Down 1, 1, 2, 3.